In some ways, object orientation is very different than previous ways of coding, and in other ways, it's kind of the same. Again, you might have coded object-oriented languages without understanding objects. Um, if you're a Java programmer or a C sharp programmer, you kind of have to deal with objects most of the time. If you're a C programmer, C++ programmer, or a Python programmer, you can ignore it a lot of times. So let's look at how objects kind of behave slightly differently than things that you've done in the past and how they're kind of just building on those mechanics as well. So the first thing is let's talk about objects versus other variables. Variables store values. So I can have temperature, which is 75 degrees, 72 degrees, 68 degrees, whatever the temperature is. That's a single value. I don't necessarily have context for that though. Temperature where? Is that the temperature in your whole house or in a specific room? The temperature varies across your house. So there's no context to that, and it doesn't necessarily relate to anything. I can have temperature, I can have humidity, and it could be the temperature inside and the humidity outside, as opposed to objects where objects group data together. They know things, they do things, and they communicate with other objects. So if I want to figure out, like something about a room that has to do, like, let's say how well a room, is a good environment for a plant to hold. Well, I want to know its temperature, I want to know its humidity, I want to know how much light is inside of there. And thus, I want to have those three variables as something the object knows about that room. And what it does is it can have a formula which says whether this is a good environment or a bad environment. But for what? What type of plant? And so I might need to communicate with another object. I have to know what plant is in this room to know whether or not that is useful. Where the variables are useful, but it's entirely up to you to take a series of variables and have them have collective meaning. Where in an object, for example, the room I was just talking about, I could have a individual little component, call it a room or a terrarium, maybe even better, specific to a plant. It could be a room, it could just be a little box, and that terrarium has a temperature, it has a humidity, it has the amount of light it gets, it has the amount of pressure that's in the air, it has the soil nutrients or something like that. And then when I place a plant in that terrarium, another object, I can ask that plant about its properties, its qualities, or whatever, and I can use the logic to, either know if the room is properly adjusted, or maybe even adjust the room. I can add in humidity, I can increase it or decrease the temperature, or whatever. And that's the idea behind objects. So the way we talk about these things in objects is we refer to what's called attributes and methods. So in the past, when you created variables, there were just an assortment of them out there. Maybe they were attached to a function, maybe they were just globally available everywhere. Well, methods are no longer just attached functions like let there be light. They are specific behaviors of, like in this case, this Instapot. An Instapot, if you've never used one, is a little amazing little cooking device that has a heater built into it, and it allows you to pressure cook things. Means you can cook things faster than you would otherwise. But the most important thing, it's self-contained, and it has all these different features inside of that. You can saute things inside of there. You can, essentially bake inside of there, or you can cook. Again, rice, soup, meat, bean, chili, poultry. All those are actually not, they're actually recipes for cooking those things inside of there. They're actually a sequence. They're a method of cooking, if you will. And so a method is a thing a object does. An attribute is a thing an object knows. So on the right hand side here, we can see the calorie contents and the ingredients and such. That's the data about the thing you're going to cook. And so if I take the object that is the food and I put it into the object that is the pressure cooker and I have them work together, well, the pressure cooker does its work using the objects of the ingredients that gets put inside of there. And then there's, chemistry and whatnot that happens to alter those ingredients as they cook. And in the software world, we can model such real world interactions by using objects. And the idea, the strategy behind object oriented software is to model the virtual objects the same way, the same information, the same behaviors of the real world objects. And so when we ask the question, what does this object know? It's based off of its attributes. It's things that are relevant to that object in the world. So if we think about the game of checkers, what are objects in the game of checkers? Well, there's a bunch of pieces on the board. Well, each piece is the same as every other piece, but each piece on its own has its own information. First of all, half the pieces are either red or black, or in this case, brown or tan. As looking at the pieces on this board, but each piece also knows its position on the board. The piece might know whether it's a regular piece or if it's been kinged. They all have the same actions. What they do is the same. We'll talk about that in a second. But what they know is dramatically different based off of very subtle things, that what side it's on and what position it's at. And they also interact and communicate with other things, which is the board. I have to know which board I'm on. The board has to know which pieces are on the board. And so objects know who they communicate with as well. So in this case, we have this idea of, we'll talk about this a little bit later, a modeling language called UML, but we have this idea of a game board which has the board itself, and it knows which player's turn it is, and then it has communication with all different pieces on the game board. And that is not shown here because that would be a relationship between objects. We'll come back to that later on. But objects know a bunch of stuff which allows them to do the work. The great part about objects knowing things is I don't have to have a view of everything of my whole program out to build a part of my program. In this case, the game board needs to know it has a board, a 10 by 10 square of where pieces can be. I have to track which player's turn it is, and I have to know which pieces are on the board. And that's all I need to know. That's all I need to do at this point to be able to solve the world. I don't need to know about who the players are. I don't even really need to know exactly all the details about the pieces. I just need to know that I have those pieces, and then I can go ask those pieces to do things for me later when I get to the methods. So the attribute describes what an object knows. But what does an object do? Well, when a piece moves, well, the movement of a piece has to relate to other pieces. I can interact with another piece directly, and in a game like Stratego, there is some rules that vary between piece-to-piece interaction. Or chess, for example, the movement varies piece-to-piece. But I don't necessarily know that for in checkers, in this case, for a piece to interact with another piece. They're all kind of the same. I jump it, doesn't matter what kind of piece it is. So the game board has a much more interesting knowledge of what the game does, how things move in the game. And so in the game board, I can have a behavior, a method called make move, which then I have some sort of indication of what move's going to happen. The move here is probably another object that says I want to move one piece from one location to another inside of there. So if you think about it, a human player makes an interaction to say I want to move a piece from here to here. Um, and that makes sense, except for in our game, the human is requesting a move. The game board is saying whether it's legal or not. The negotiation between two humans in a real world scenario determines whether a move is legal. I mean, theoretically, you could cheat and break the rules between two humans if you want to ignore certain rules. But in our scenario, our virtual world, the game board is enforcing the rules, and the human creates a request for a move, which is that move object we're out there. So when we think in terms of object orientation, it helps us to organize the real world into the gestures a human might make. Because a human can't directly interact with the pieces, they do it through the virtual world. It allows us to separate out the human's intent versus the actual legality of what they want to do, in this case of the checkers game. All right. So a method, as I said, comes down to what an object does. And as we talked about, there's communicating with other objects. The board needs to know about the pieces, but it also needs to have an interaction with the player. And so when we have, in this case, a game board and player, there are two different types of objects. Actually, this is what's called a class. A class is a prototype. It's the way you define an object. And notice in this case, a game board, which there's one of them, interacts with two players potentially. You see the two in between the line. And we're saying this game board keeps track of two players, and each player, for example, might have a name. Again, I don't need to know everything about the player. If you think about the virtual game of checkers, really, if I have the player's name, that's good enough. The player's going to tell me what it wants to do. For example, what move it wants to make. It wants to move this piece from this location to that location. So the interactions between objects, how do they communicate, are kind of like attributes, and they'll show up as attributes in our code, but they have a very distinct role in our model. They are the interactions between objects that help us to achieve the larger goals.